this question asks us to draw the mechanism for the acid-catalyzed formation of IPP from DPP. To do that, we'll use just a generic acid. We'll just use HB as our generic acid. What will happen is that this alkene in the starting material will act as a nucleophile, and the electrons in this alkene will attack the hydrogen of our generic acid, protonating the alkene, kicking out B- as a leaving group. That will form a carbocation intermediate. Markovnikov's rule says it will form the most stable carbocation possible, and we'll have the rest of the diphosphate on our molecule as well. From this carbocation intermediate, we will use a base, the B- that we formed in the first step perhaps, to take a proton from carbon number 1 to regenerate IPP. The lone pair of electrons on the B- will grab this hydrogen. That will break the carbon-hydrogen bond. Those electrons will shift over to form the new alkene, which will form our IPP product. How do I know that this is the correct mechanism? Because of the principle of microscopic reversibility. Principle of microscopic reversibility says a reverse process must be exactly the same as the forward process, just backward. In the forward step, the forward reaction, the alkene and carbon 1, carbon 2 reacted with a generic acid to form a carbocation intermediate, and a base took the hydrogen on carbon number 3 to form the DPP product. The formation then of IPP from DPP must be exactly the same, just reverse. The first thing we'll do is we'll reform that carbon 3 hydrogen bond, and then break the carbon 1 hydrogen bond to reform the alkene. This is the acid-catalyzed mechanism for the formation of IPP from DPP.